Consider the accompanying graph of f of x is equal to kx to the n, where n is a positive integer. Let's start with part B. We're asked, is k greater than 0 or is k less than 0? Well, we notice that k is the coefficient of x to the n. We can determine the value of k by evaluating f of 1. We simply substitute 1 for each x, and we get k times 1 to the n. Now, even though we don't know what n is, we do know that it's a positive integer, and when we raise 1 to a positive integer, we get the number 1. For example, 1 times 1 is equal to 1. 1 times 1 times 1 is equal to 1, and so on. So 1 to the n is 1. 1 times k is k. So f of 1 is equal to k. Now we can look at the graph to estimate the value of f of 1. We locate 1 along the x-axis and go down vertically until we hit the graph of the function. Then we go horizontally across to the y-axis, and we see that the corresponding y value is approximately negative 1. So k is approximately negative 1. Negative 1 is less than 0, so k is less than 0. Let's go back to part A. Is n even or odd? Let's use our calculator to explore. Go to y equals and enter k times x to the n. To enter k, use the alpha key. Alpha, k, and then times x raised to the n. Alpha, and then locate the letter n. Next, go to the home screen. Press second mode to quit. We've determined that k is approximately negative 1, so our first step will be to store negative 1 as k. Enter negative 1 and then store that as the letter k. Okay, we now want to determine what is the value of n approximately so that we can determine whether it's even or odd. Well, we know that n is a positive integer, and the smallest positive integer is 1. So let's start off with 1. 1 store n. The next thing we want to do is to determine a good viewing window, one that matches the given graph. So we go to Window, and we notice that along the x-axis the values range from negative 5 to 5 with a scale of 1. So we enter negative 5 for x minimum, 5 for x maximum, and 1 for x scale. Along the y-axis our values range from negative 10 to 3 with a scale of 1. So our y minimum is negative 10, our y maximum is 3, and our y scale is 1. Next we hit graph. Notice that when n is 1 the graph is a straight line, and since k is negative it's a decreasing line. So n is not equal to 1. Let's go back to the home screen, press second quit. Okay, n is not equal to 1. Maybe it's equal to 2. So we get 2 store the letter n. When n is equal to 2, the graph looks much closer to the given graph. However, the given graph looks a bit narrower than the one that we have on our calculator screen. In order to see the difference, let's use the trace key and determine the y value when x is equal to 2. When x is equal to 2, the y value is negative 4. Let's compare that with the given graph. We first of all locate 2 along the x-axis, and then we go down vertically, but we don't hit the graph of the function. What this indicates is that f of 2 is less than -10, because -2 is the smallest value along the y-axis, and our vertical line at x equals 2 did not intersect the graph of y is equal to f of x. So on our calculator screen, the y value at x equals 2 is -4. That's not small enough. So that tells us that n does not equal -2. So we go back to the home screen. Let's try 3. Go back to the graph. And we can see that when n is equal to 3, the function is always decreasing. But our given graph increases to the left of the y-axis and then decreases to the right. So it looks like we can rule out n being odd. N is not odd, n must be even. Let's try n is equal to 4. This graph looks much closer to the given graph, and when we trace and determine the y value that corresponds with x is equal to 2, we get y is equal to -16, which is less than -10, and so the given graph is likely a graph of f of x is equal to minus x to the 4th power. The key thing for part A is that we've determined that n is even.